Let's imagine a world for a second. A world where building cutting-edge technology, I'm talking about the actual silicon chips that power our entire lives, isn't just for a few giant corporations. A world where innovation isn't locked behind closed doors. You know that world? It's actually a lot closer than you might think.
I mean, really think about that. What if a student in their dorm room, an entrepreneur tinkering in their garage, or a researcher at a small university could design and build a totally groundbreaking new computer chip? For decades, that idea was, well, it was pure science fiction. But now, it's becoming a reality.
So what we're seeing is this really fundamental shift. We are moving away from the old way of doing things. All secrecy and exclusivity, dominated by billion-dollar factories and these elite walled-off teams. And we're moving toward a totally new model. One that's built on open blueprints, tools that anyone can get their hands on, and a vibrant global community of creators. This is the big change. And frankly, the new way is winning.
So how do we even get here? In this explainer, we're going to start by looking at the old guard of silicon and the massive walls they built. Then, we'll get into the revolution that's tearing those walls down, and we'll see who it's empowering. We'll look at the real-world impact this is having right now. And then, we'll peek into the future and talk about the secret ingredient that makes this whole thing work, the community.
Okay, first things first, let's really understand the problem we're talking about. For the longest time, the world of chip design was basically a fortress, with these incredibly high walls built to keep pretty much everyone out.
And you have to understand, these barriers all fed into each other. The costs were absolutely astronomical, mostly because you needed these super expensive, highly proprietary software tools. The development cycles took forever, and even if you got through all that, it all ended with you needing access to a multi-billion-dollar factory, or fab. It was a completely closed loop, a super exclusive club.
And the result of all that? Well, it's pretty obvious when you think about it. You create an innovation bottleneck. So many great ideas were just being left on the table simply because the people who had them couldn't get through the gates. The system itself was actively limiting who was allowed to build the future.
But here's the good news. Those walls, they're crumbling. There's a powerful new movement that is just shattering the old ways of doing things, and it's sparking a full-blown revolution in design.
And it's all thanks to something called open source hardware, or OSWH for short. The definition itself is simple, but its implications are profound. It just means the digital blueprints for physical hardware are made public. Anyone can see them, learn from them, improve them, and most importantly, use them to build their own stuff.
Now, if this whole model sounds familiar, it absolutely should. We've seen this exact same playbook completely transform the world of software. I mean, Linux pretty much powers the internet, Android powers billions of phones, and they're both built on open source principles. OSHW is just taking that same powerful idea and applying it to the physical world of silicon chips.
Okay, so that begs the question, right? If this idea is so powerful, why is this revolution happening now? What changed to suddenly make all this possible?
Well, it wasn't just one thing. It was more like a perfect storm of three huge breakthroughs happening all at once. First, the software tools for designing chips got way more powerful and way more affordable. Second, new fabrication services started popping up that let smaller projects share the immense cost of production. And third, the internet, of course, allowed these global communities to form and collaborate and share knowledge like never before.
So what happens when you have that kind of tipping point? The result is a massive transfer of power to a whole new generation of innovators who, up until now, were completely locked out.
For hobbyists and makers, I mean, this is a dream come true. Imagine you're building a custom drone, and instead of trying to hack a generic, off-the-shelf component to work, you can actually design a chip specifically for its flight controller. That's the kind of power OSHW puts in your hands.
And for startups? Oh man, this just cracks the entire market wide open. You no longer need tens of millions in venture capital just to get a hardware idea off the ground. Now you can build these highly specialized products for niche markets and innovate on a lean budget. It just completely lowers the barrier to entry.
And for researchers, the impact is, well, it's immense. Science just moves faster when you're not constantly reinventing the wheel. OSHW lets scientists build directly on existing open designs, and it makes it way easier for others to verify and reproduce their experiments, which speeds up the pace of discovery for everyone.
So when you put it all together, the hobbyists, the startups, the researchers, you get this. This is what it really means to democratize silicon design. It's a fundamental shift, moving the power to innovate from just a few giants to this massive global network of contributors.
And look, this isn't just some feel-good theory. Let's talk about the concrete impact this is having in the real world right now, moving from digital blueprints to actual physical silicon.
The proof is right there in the projects. I mean, you have to look at something like RISC-V. It's an open-source instruction set, which is basically the fundamental language a computer chip speaks. For decades, these languages were totally proprietary. But RISC-V is a free and open alternative that's now a major competitor to the big players. It's this thriving ecosystem that proves the model doesn't just work, it excels.
You know, the implications here go so much further than just cost. When designs are open, they become transparent. Literally anyone can audit them for security flaws or hidden backdoors. This drastically enhances the security and the resilience of our tech supply chains, which has huge positive effects on everything from the gadgets you buy to national security.
And believe it or not, this is really just the beginning. The foundation has been laid, and what's going to be built on top of it? That's where things get really exciting. The future of hardware is undeniably open.
And the applications that are on the horizon are genuinely mind-blowing. Think about highly specialized AI accelerators, custom-built for one specific task, doing it faster and more efficiently than any generic chip ever could, or a Cambrian explosion of niche Internet of Things devices for every purpose imaginable, and incredible new educational tools that can give students hands-on experience designing real silicon. The potential is just vast.
So, as we wrap this up, I want to focus on the single most important element in this entire revolution. It's something that goes way beyond the technical blueprints themselves.
Here's the most important takeaway. The technology is the enabler for sure, but the community is the engine. The true strength of open source hardware is that global network of people sharing knowledge, debugging designs together, and collectively pushing the boundaries of what's possible. That collaboration, that's the real superpower.
For the first time in history, the power to innovate at the most fundamental level of technology is truly moving into everyone's hands. So it's no longer a question of if we can build the future. The question is, for all of us now, what will we build next?